Hi everyone, thank you for joining. So in this video we're going to talk about length contraction, which is again one of the peculiar concepts in special theory of relativity. In the previous videos we talked about time dilations and some experiments confirming time dilations. And of course, if there is such a thing as time dilation, since time is not detached or separated from space, it will have consequences that if time is behaving in a strange way, that's strange to us based on our classical perception of time, that means that we're going to, this will have some consequences in space. Okay, so today we're going to talk about space. So just like in time dilation thought experiments that we have, we are observing the first system from Earth, and we have a rocket traveling from Sun to Saturn, and we said the distance between them is L, right? And we're observing this from Earth, and the second picture here, a stashed frame, we're observing it from the rocket, so we are inside the rocket, yeah? And we call that distance L dashed. We don't know whether L and L dash is different. That's what we're going to test, okay? So one of the wonderful things about relativity is that we can still use our GCSE formula for speed distance time relation. So we have velocity is equal to delta L, delta T. But the speed V is the relative speed between S and S dashed. Yeah. Since it is relative speed between them, it must be the same for experimenters in both reference frames. In other words, this must equal to L dashed over delta T dashed, right? Now, of course, one thing we need to remember that the time here, the delta T dashed, is a proper time. Why it's a proper time? Because the both events occur at the same position in frame S dashed, and it can be measured by one clock only. So that's the proper time. Yeah, and using the formula that we derived for the time dilation, which is 1 minus b squared square rooted delta t, right? From the time dilation where b is equal to v over c. So comparing these two formula and that, we can get rid of delta t. So we're going to have, if we make L dash the subject, L dash will equal to square root of 1 minus b squared times L, right? Okay. Now this is very peculiar, and why is it very peculiar? Well, the reason for that it is saying something very profound about the space. That it is saying the length measured by S dashed frame will differ from the length measured by S frame. So in other words, the distance between two objects in one reference frame is not the same as the distance between two objects measured in the other reference frame, right? So when we're talking about vacuum, like empty space between the Sun and the Saturn or anything else, it may not sound very peculiar, but this is true even for a solid object. Let's say that you're driving your car at a high speed so that the effects are noticeable. So the length of the car, you will realize the car will shrink. So the length there will be less than length here, right? Okay. So this is saying something very peculiar about the nature of space. But one thing to remember, of course, the Einstein uses this word relativity, one might say ironic way, because he's interested in objectivity and objective reality. Just like in the time dilation, we defined what was proper time is. Now here we defined what is a proper length, right? I'll write it down for you. Okay, so this is the definition of proper length. What is a proper length? Well, it is distance L between two objects measured in the reference frame in which the two objects are at rest, okay? Just like here, in the first picture, two objects here, Sun and the Saturn, were at rest. And that's the definition of proper length, okay? Now, it's quite remarkable, is actually, for observer at L dashed, the length contracts. And this is the famous length contraction formula here. and the space has this property that it shrinks for this observers at s dashed. Okay, therefore we define a proper length as given here. All right. Well, I hope you found it interesting and inspiring. We're going to do perhaps a question and a paradox on this in the next video. Right. Thank you so much for joining. I look forward to seeing you in my future videos. Thank you.